let's give us a countdown.
Alright, 3, 2, 1. Hi, I'm Kayla Buchholz.
I'm Carson Stabell. Noah Wertza. I'm Kurt Walker. I'm Sam Dunn.
And what you're watching is a presentation of the Capstone Labyrinth project. As a part of the Capstone initiative, computer science majors get the chance to use their skills in a real-world scenario. Individuals get the choice to make teams on their own or be assigned one to work and design on a product that would be tested outside of their academic classes. Students may choose from a number of listed projects or decide to make a project of their own. Our team, the Capstone Labyrinth, decided to go with the latter. From the first day, we were enthralled by the idea of building and developing our own video game. Our idea in the very beginning was to create a game that involved players moving through a maze to fight enemies. Originally, we proposed that these other enemies could be other online players in a battle royale that takes place inside of a maze. As the game developed, however, we soon started thinking in terms of and designing towards a single-player game instead. Early on, the idea of theming the maze in a horror genre was suggested. Soon after that, we all hopped on board with the idea of building different sections of the game, each designed in a different horror style. Styles like Dollhouse and Haunted Mansion did not make the cut, but other styles like the Dark Water Docks and Meat Locker stuck through to the end. The walls of the maze were implemented on 3 different levels. The first layer was simply defining a single square of wall structure and placing that in its own separate header file. The second layer was using that single wall structure to create more complex 3x3 sections of walls. These sections included corners, T-sections, hallways, dead ends, and many more, as well as ways to implement these sections in every direction. The last layer of building included designing the maze by dividing it into 4 different quadrants. Each section was again coded into its own header file. This made it easy to implement the wall and floor designs when time came to represent these quadrants visually as well, eventually turning this scene, as it was originally built, into the final landscape that you'll see here in just a few minutes.
Hi, this is Sam Dunny again, and I'm here to present a review of the technology we used to design our Capstone Labyrinth game. For our game, we used this Visual Studio's 19 IDE combined with the C++ SFML library to write a C++ object-oriented project. We also used the native Microsoft CPP unit test framework for our unit tests. SFML is a multimedia library designed for the C++ language and allowed us to integrate custom graphics and audio into our game. Using Visual Studio's 19, we statically linked the SFML library to our project to create a portable desktop executable game. Within the project itself, functionality is split into different header files which can be broadly grouped together. First, we have our animations, responsible for animating the enemies and the player, as well as the replenishing items. Next, we have collision detection, responsible for making all objects quote-unquote physical, which enables contact between all in-game items. Next, we have our walls and background, which are all the maze, wall, and background files. These are the building blocks of the maze, and are implemented with a custom maze designed for each maze section. Following, we have our individual, which encompasses player and enemy, and by extension spawner, and this encompasses the player and enemy objects. Next, we have our menu, which allows the player to use custom settings or to restart the game. And last but not least, our game engine. We designed a from-scratch C++ game engine that is responsible for running and operating the entire game. We did run into some technical difficulties early on trying to get an executable to successfully build. Initially, we were using Visual Studio Code, but switched to VS19 so we could successfully build a .exe file. At the same point in time, we also switched our target platform, moving from Linux to Windows for the added security a Windows desktop game entailed. Overall, the combination of VS19 and the SFML library has worked well, except for an issue with image referencing within the executable, which forces us to run the .exe from a specific directory within the project.
Hey, my name is Kurt Walker, and I am the Chief Art Design on this project. And what that means is I designed most of the pixel art that you'll see within the game. The main menu, I designed most of these things, most of these sprites inside the game, and I am just going to take you on a little tour on how I did that. So I used a website called Pixel Art to design all the sprites and textures in the game. They have 32 by 32 presets, which is the size that we used for the art. We had 4 different themes. We had the ruins, we had the docks, we had the meat locker, and we had the sewers. As you can see here, these are all the textures that we used for those. You can see here we have the main character's sprite sheet. It is divided into 9 parts. These top 4 are the running animations. The middle one, the fifth, is the idle animation, and the bottom four are the attack animations. As you can see, each animation is 4 frames long, and how this works is, in the code, if we go to player, it detects if player is standing still, and if that's true, then it runs row 4, which is the idle animation. If the character is moving left or right, then it shows this row, which is automatically flipped in the code based on which direction they are looking. If they are moving up or down, obviously it shows one of these two. For the attack animation, if the spacebar is pressed, it does basically the same thing, depending on which row is already being shown, which means that we can tell which direction the player is moving. It pulls the appropriate attack animation from here. This character was actually inspired by another sprite used by the game Hyper Light Drift. They have just the most beautiful running animations and attack animations, so I used that as kind of a jump-off point to create these animations. As for the floor and wall textures, those mostly came out of my imagination. We met early on and decided that the maze was going to have 4 themes and what those themes were going to be. And these were what we decided on, so we were able to take some creative liberties with designing the maze in such a way. It was really fun getting the textures to line up throughout both of them, try and make it so that it created a consistent flow of the waves when the textures are all lined up next to each other. The animations for the minotaurs and the health bars and the hearts were actually free online resources that we were able to find. So hopefully you have a little bit more understanding about how the artwork in the game came about and our thought process behind making it. I'm really happy with how it all looks, and I hope it looks good to play. Thank you.
Hello, my name is Noah Wertzak, and I'm going to be walking through the sound implementation for our game Capstone Labyrinth. As a player starts in the middle using the arrow keys to move, the first sound you might notice throughout the maze is the background music. This music is played on a continuous loop throughout the duration of the player's stay in the maze. Next is some combat noises. When a player is engaging in combat with an enemy, you can hear when a player takes damage from that enemy. With a simple punching sound, and now the enemy is dead, and you can hear an enemy death sound as well. Now that my health is nearly halfway down, I need to regenerate my health. There's a noise following that, picking up the heart. Next, I'll be walking through how to implement these sounds and my process of doing so. Continuing what we learned about sound in the first part, I wanted to start off by talking about the sound files themselves. I used a website called freesounds.org, which is an individual creator website that allows people to share and download other people's sound bites. I used .wav files consistently throughout this project, and that was done strategically, as MP3s aren't supported by SFML due to patent infringements. Moving on, I wanted to talk about how the sound was implemented. Given that SFML has a sound library that we're able to use, it made the implementation a little easier. Although running into linking files with an open audio library file at the beginning, I was able to implement both background music, music for combat, as well as music for health replenishing. So as you can see here, you define a sound as a sound buffer, and then load in that sound file. Next, you just have to decide when and where to play it. I wanted to loop the background music because it was only a short audio file, so I looped that upon entering the main menu. Moving on, I have defined the health replenishing noise in a different header file, and then you call it for each time that a heart is picked up. I wanted to dull down some of the noise volume as not to overwhelm the player with startling loud noises. That's all for sound.
Hello everyone, my name's Carson, and I worked on a lot of the menu stuff for Capstone Labyrinth, so I'm going to take you through and kind of show you how it all works. So to start with, as soon as you boot up the game, you'll be greeted with the main menu, and with this, you can use the arrow keys to navigate. You can also use the mouse. That was quite the challenge in order to get that working. Click on the instructions, it'll show you instructions, options, show you options, and also if you click enter, it'll bring you to the main game. And if you hit escape, so to kind of take you through exactly how everything works, the main kind of structure to how the menus work is our menu.h class. How this works is it stores all of the necessary information for the menu, as well as it will kind of build a basic menu that you can then edit in the different types of menus. So how it works is first loads a text file, a text font file. In this case, we're using something that looks very similar to Papyrus, but is open source, and then it generates an array of all of the different text items in there, and it does this using the built-in text class from SFML. So down here, it'll set up buttons using standard textures. That's essentially the background of it, and here you see the mouse update that's built into menu. Essentially, it'll get the position of the mouse every frame that it runs, and then basically run a collider between whether or not which button you're closest to. And then if you click, it'll select the button that you're closest to, and it also changes the highlighting here. You can see it'll change the one that was previously selected to white and change the new one to red. So to take you in, this is the main menu header file. You can see it needs to start with a pointer to a menu class. It'll look to see if the window is currently null, see whether or not it got past a window value. If it didn't, then we'll create a new window, and then it'll create a new menu, and it passes in the width and height, as well as the number of menu items that we want to create with our main menu. And then what it'll do is it'll update every frame of the game, and it'll pull for whether or not the mouse moved. So if the mouse moved, it'll call mouse update through menu, and if the mouse button has been released, so if you release the left mouse button, then it will find which one the mouse is closest to, click that one. Otherwise, it uses standard keyboard up and down. You can also use W and S. And then Enter will call the item selected. So here, item selected, this is where you assign the attributes to each button. You see case 0 is just the main play button. Main play button, 1 is options, 2 is instructions, 3 is to close. Just exit. So the main menu will actually call the options and instructions menu, and I'll show you the options menu here. Very similar to everything else. You can set different attributes. So it'll check to see whether or not the cheating value is set already. So if the cheat mode gets selected or deselected, it'll either set it to false or true. So that's the only option we have in there. So this is in main CPP. When it initially first runs, it actually calls the main menu first, and then based on what the main menu code exits with, it'll either start to run the game engine or it'll exit the game itself. And when you run it, when the window closes, it's treated the same within SFML. So we return the code 0 if we want to run the game, in which case the game runs. Or we return 1 if we want to just exit. That should be about it. There you go.
Little game started out as merely an idea, but through teamwork and many, many hours of rigorous labor, we were able to turn it into a proper game that you can now play. Here.